Today's kind of the day that we put it all together. So on day one, we practiced something like this, where we were just looking for the rational root. Day two, we solved quadratic equations. We found the imaginaries and the square root of 2. Today we're going to put this together where we don't just find the rational, we find all of them. Now our whole goal for this is to get all of these roots to a quadratic. Once we have them as a quadratic, then we can factor. Or we can use the quadratic formula. So that's kind of our big goal here. Now we got to put together everything we've learned. Okay. And then if we're highlighting things, our whole goal, we need to be left with a quadratic. That's what I just said. At that point, once we have a quadratic, we'll either factor it or we'll use the quadratic formula. Okay, we could use the discriminant to decide how to handle the quadratic we get at the end. I don't though, I just try to factor, and if it doesn't factor, then I move on. I feel like that. No. Okay, so looking at this one. If you start with a cubic third-degree polynomial, there's one trick that might help you. Sometimes they factor by grouping. We already knew that, right? I think that maybe factoring by grouping will be easier than using synthetic formula and guessing. So that's what I'll try first. Remember how to factor by grouping? Here's my pencil pick. So we'll group those first two. Out of the first group, what do they have in common? An x squared. Go through. What are we left with? X minus 2. In the second group, what are we going to have to pull out? A minus 1. What are we left with? X minus 2. They both have x minus 2. If I pull that out, what are we left with? X squared minus 1. At this point, this is a quadratic, right? I'm still going to try to factor it. If it doesn't factor, I'm going to use the quadratic formula. Does this one factor? This one you should look at automatically and say difference of squares. It should be almost to that point, where you have a perfect square, and a minus in between. If I were playing a game, I would have to multiply to -1, add to 0. And what multiplies to -1 and adds to 0? +1 and -1, right? Now, if the question asks me to factor it, I'm done. If the question asks me to solve, then I have to set each of them equal to 0. Does this one say anything? It doesn't. So let's pretend like I said solve. Okay, so if I have to solve this, equals 0, what do I do? Yeah, each of these terms are equal to 0, right? This one equal to 0, x equals what? 2. This one equal to 0, -1, and this one, +1. So that one we would be done. Okay, example 1. Solve each of the following cubic equations by factoring by grouping. I really don't want to. You feel like okay, let's do another one. Alright, looking at that first grouping, what does it have in common? An x squared, we're left with x minus 3. The second grouping has a minus 4. Will you guys finish this off for me? I'm going to do this one to see if anything weird happens. Okay, yeah. Okay. Yep. Well, it's recording, so you can watch it. Good luck. It's a hard class. I don't know how to answer that question. It's not anything incredibly new. Good luck. Have a good weekend. Okay, go back to this one. They both have an x minus 3, right? Then you have an x squared minus 4. Is that a difference of squares? Yeah? Okay, so this one is going to be x minus 3. Then what? X minus 2x plus 2. And if I had to solve that from this factor, what would x equal? From this one, it would be 2. And from this one, negative 2. Okay, how do you feel about that? That problem right there. Okay with that one? Now look at part B on this one really quick. I factored by grouping, pulled out an x squared, well, and so I'm getting to this point right here. Will you just start right here? Just write this one down. Yeah? What? So on this one, right here, it's pretty easy. X equals negative 5, right? Does this one factor like difference of squares? No. I need to show you another way to solve an equation like this. You know what I'm doing. Come off to the side. X squared minus 5 equals 0. We can still set it equal to 0. You could plug it into the quadratic formula. If it had a middle term, I definitely would plug it into the quadratic formula. Lee. Yeah, you sure do. So let's add 5 over. So x squared equals 5. And then how do you cancel a squared? You square root it. But if you are the person putting the square root on, you have to do a plus or a minus. That's how the plus or the minus happens in the quadratic formula. So x equals negative 5 from right here. From here, it equals plus or minus the square root of 5. And that's all 3 solutions. So if there's no middle term, and it doesn't factor nicely, I guess we could have done this one the same way. That's what I would do. All right, let's move on. For polynomials that cannot be easily factored, so there's only 2 examples of this. I think we're probably going to have to try a couple of them in your homework as well. So darn it, right? For polynomials that can't be easily factored by grouping, we need to use the tried and true combination, whatever. So here's some steps. The first step, see if there's going to be anything that can be factored out of every term. Is there a number that divides evenly, or does everyone have an x in it? So you'll look for that first. It's kind of an important step. And then from there, I'll just show you. Okay, so in example 2, here's how it would start. I first notice that each term has a what? An x. So I'm going to factor it out. My whole goal is to get this so it has a quadratic, because as a quadratic, I can use the formula or I can play the game. But I'm not there yet. So in order to get it to a quadratic, there's really only one thing that you can do, and that's, yes, that's synthetic division. So ignore this x for a minute. Is that okay? Looking just at the cube, the squared, the linear, the constant. Now you may want to ask yourself what possibly could go into this equation. If I were listing my p over q, the p is 3, right? So plus or minus 1, plus or minus 3. So q is 1. So these are the only choices I have to put into the synthetic division. I don't know which one it is. I've not done this problem before, but where do I start every time? Start with 1, see if it works. Minus 1? I don't know. Bring down the 1. 1 times 1 is 1. Add, you get negative 4. Multiply, you get negative 4. Add, you get 3. Multiply, you get 3. Add. Where? Plug it into what, though? Back. So you're just like plugging the 3 in, plugging the 2 in? Yes, but the problem with that is, it's like when you plug it in, it's really hard Are you saying to figure out what goes here? Yeah. The only problem is if you have to find every single zero, if one's used twice, you plug one in once, how do you know? Does that make sense? Like, yeah. Okay, so right here is our first solution, right? We skip this right here. Can we get our second solution really fast? So from this right here, what does x equal? 0. So I got a 0, I got a 1. What do I do from this part? Is this a quadratic? Yes. At this point, I can change it back to a quadratic and factor. Or at least try to factor. If it doesn't factor, that means my answers are square roots or imaginaries. Okay? Or both, yeah. We'll get there. So it doesn't factor. It needs to multiply to a 3, add to negative 4, x minus 3, x minus 1. Okay, so let's list all of our zeros now. X equals, it doesn't matter the order, from right here, x equals 0. From right here, x equals 1. From right here, x equals 3. And from right here, x equals 1. Woohoo! I love this stuff. That would be a great joy. What's that? Kind of, yeah. But now we're just putting it all together. So up until now, if this doesn't factor, we've stopped. Today we're just going further. It's a double root, so if I were to graph it, it means it would cross right here, it would cross right here, and then it would bounce off of this one. Let me see. It would look like this, and then it would bounce off of that one, and then go back up. The double root. So one can be listed twice. So this one came from there. This one came from there. Any other questions? Really quick, I'm going to be very blunt. I'm not going to help you after school on this if you're not paying attention right now. Sound good? Okay, let's do the next one. So we start. Is there anything that they have in common? No. I'm just going to look at it. If I were to group it, would anything come out? This would be like an x minus 9, and this would be a 21, 11. No, that doesn't work either. So from here, what do you do? Yeah. Now we have to kind of list our possibilities. This is the P, this is the Q. So if it's P over Q, the factors of P are 1 and 11, yes? The factors of Q are just 1. So these are my only choices. Why don't you try it? See what you get. Try something. You know, I'm trying to make sure everything's in okay. Just try something. Can you find one that works? Does 1 work? No? Negative 1? Okay, negative 1. 11 works as well. Okay, so 1 times a negative 1 is negative 1. Add, you get negative 10. Multiply, you get 10. Add, you get negative 11. Multiply, you get 11. Add, you get 0. So my first solution is here. Now I heard 11 worked. So we could use the synthetic division again, or we could the factoring. What do you want? Factoring. Okay, so if I factor, this is x squared minus 10x minus 11, right? How does that factor? Yeah, it needs to multiply to negative 11 add to negative 10. So that would be negative 11 and 1. So what's my answers? From the very beginning, x equals what? Negative 1. Then what? From here, x equals 11. From here, negative 1. And that's everything. Good. I'd like to do a couple from your homework, just because I don't think that was enough practice, because you're right, this is what we've been doing. But first I'm going to end my recording, so thanks for watching. Peace out.